Hello, everyone, and welcome back to the intro algebra video lectures. Today, we are going to be covering some more evaluating and simplifying variable expressions. We've done a little bit of this in previous videos, but today we're going to be covering evaluating and simplifying variable expressions in more detail. So, just as a reminder and a recap of evaluating variable expressions, to evaluate a variable expression, that means that you are going to plug that number in to the variable into every single place you see the variable appear in the expression. Now, especially as we saw in the last video, there can be hidden multiplication between a number and a variable. When you're plugging a number in for a variable, please always use parentheses, especially when there's hidden multiplication there. And also remember that when your variable expression involves more than one operation, to simplify it, you need to follow order of operations when you simplify that expression. We've covered order of operations in the previous video, so if you need a refresher on this, go back and rewatch that previous video. Now, just as a reminder that if the same variable appears more than once in that variable expression, you are going to plug that value into that every single place you see that variable. So if you have more than one of the same variable, you might have to plug in your value more than once. Now, this process for plugging a number in for a variable is called substitution, and we're going to call it substituting a little more formally throughout this video. So what we're going to do is we're going to evaluate each of these variable expressions for the given value of the variable. So we're going to start with the expression x minus 3, and we're going to evaluate that when x is equal to 20. So what I'm going to do is I'm going to take 20 with parentheses around it, and I am going to plug it in to the expression into every single spot I see in x. Since x only appears right here, I'm going to plug 20 in for that x right there, and anything that is not an x needs to be left alone and left exactly where it is. So this x will get replaced with 20, and then I'm going to leave that minus 3 alone. Then 20 minus 3 gives us 17, and then 17 is going to be our final answer. Now for this next one, we're going to take the expression negative 2x plus 1, and we're going to evaluate it when x is equal to 3. Now here is where it is extremely important that you use parentheses when you're substituting 3 in for x, because there is hidden multiplication between this negative 2 and this x right here. So you do need parentheses around this 3 to indicate that this is not going to be a negative 23 when you plug it in. This is going to be a negative 2 times 3. So I'm going to take 3 with parentheses around it, and I'm going to plug it into my variable expression into this spot right here that we see in x. Anything that is not an x needs to be left alone and left exactly where it is. And because I'm going to need more room than this, I'm going to continue this over here on the right. So I'm going to leave that negative 2 alone, and then in place of x, I'm going to substitute 3, and then I'm also going to leave that plus 1 alone. And then if your variable expression involves more than one operation, which this one does, you need to follow order of operations when you simplify it. So here between the negative 2 and the 3, there is multiplication, and I have addition. In order of operations, which of those would go first, multiplication or addition? Multiplication would go first, so I'm going to do the multiplication first. So negative 2 times positive 3 is going to give us negative 6. Then I am going to add them. Negative 6 plus positive 1 is going to give us negative 5. So our final answer here is going to be negative 5. Then for this next one, it is extremely important that you use parentheses, especially when your variable expression involves an exponent. So here we have 3 times x to the power of 2. Since x is being squared, when you substitute any value in for x, you have to use parentheses, especially if the number that you're plugging into x is negative, which it is. So we're going to evaluate this when x is equal to negative 3. So yes, please, you must use parentheses here. So I'm going to put parentheses around the negative 3, and then I'm going to take all of this, parentheses and all, and I'm going to plug it in for where I see the x. And now I'm just plugging this in for x. The 3 is going to be left alone, and the exponent of 2 is going to be left alone. Anything that is not an x needs to be left alone and left exactly where it is. So I'm going to do this off to the right here since I need more room. So I'm going to leave the 3 exactly where it is. And then I'm going to replace x with parentheses -3. And then I'm going to leave the exponent alone, and I'm going to make sure that the exponent is outside the parentheses. And again, when you're substituting a number in for a variable and that variable is being raised to a power, you must use parentheses because both the negative and the 3 are both going to get squared. This parentheses are going to group together the negative and the 3 so that they both get squared. Now we have more than one operation. There is hidden multiplication here, and we have an exponent. So in order of operations, which would go first? Exponent would come before multiplication, so I'm going to do the exponent first, which means I'm going to leave this 3 times alone, and I'm just going to take -3 and raise it to the power 2. So -3 times -3 will be +9. Then you can either leave the parentheses there or replace them with the multiplication dot, whichever. This now becomes 3 times 9, which is 27. So you do have to keep that in mind, that order of operations always applies even when you are evaluating variable expressions. Now this next one is an example of a variable expression where the same variable appears more than once. We have the expression x squared minus 2x plus 1, and we're going to evaluate that when x is equal to -1. So if your variable appears more than once, you're going to plug -1 with parentheses around it into every single spot that you see that same variable. And again, especially with hidden multiplication that's right here and the exponent that's right here, parentheses are absolutely required. So I'm going to take -1 with parentheses around it, and I am going to plug it in both into this x right here and into this x right here. Anything that is not an x needs to be left alone and left exactly where it is. So I'm going to take x and I'm going to replace it with parentheses -1. I'm going to leave the exponent alone and make sure it's written outside the parentheses. Then I'm going to leave this -2 alone, and I'm going to replace x with -1 with parentheses around it. Then this +1, I'm going to leave it alone. And then we have a lot of different operations here. So let's go through. There's nothing to do in the parentheses since the parentheses are just grouping the negative and the 1 together. So I have exponents, subtraction, and addition, and multiplication. So of those operations, which one of those would go first? Well, exponents are going to go first, so I'm going to do the exponent and just kind of leave everything else alone for now. So the exponent, because there are parentheses grouping the negative and the 1 together, that means both the negative and the 1 are both being squared. So this becomes -1 times -1, which is +1. And then everything else I'm just going to kind of leave alone. Then, after that, after exponents comes multiplication. So the hidden multiplication that's right here, I'm going to do that next. Now remember that a number always takes the sign to its immediate left. So I'm going to leave this 1 over here alone, and I'm going to leave this +1 alone. And what I am multiplying together is this -2 times -1, since both of these numbers took the signs to their immediate lefts. So a negative times a negative is a positive. -2 times -1 is +2, which I'm going to indicate with that plus sign. I'm out of room, so I'm going to have to move it over here. And now I'm going to do the addition. So you can either do the addition all at once if you're comfortable with that, or you can just do the addition in the order that they appear when you read this from left to right. 1 plus 2 is 3, and then 3 plus 1 gives you a final answer of 4. So 4 is going to be your final answer. All right, and then for the next one. For the next one, we have the expression x squared divided by 2 minus x, and we're evaluating this when x is equal to -4. So what I'm going to do is I'm going to take -4, I'm going to put parentheses around it because parentheses are required, and I'm going to plug it into this expression into every single spot that I see in x. And since x appears more than once, I'm going to plug -4 into each of the places x appears. So I'm going to be plugging -4 in right there and right there. And in this expression, anything that is not an x needs to be left alone and left exactly where it is. And again, parentheses are absolutely essential, especially with exponents. So in place of this x, I'm going to substitute -4 with parentheses around it, and I'm going to leave that exponent of 2 alone. I'm going to leave the divided by alone, and I'm going to leave the 2 on the bottom alone. I'm going to leave this subtraction that's right there. Again, I'm going to leave it alone. And then in place of this x, I'm going to replace it with -4. So then let's follow order of operations. So nothing to do in the parentheses since the parentheses are grouping together the negative and the 4. After parentheses would come exponents. So I see an exponent right here, and I'm going to do that first. I'm going to continue over here. And because there are parentheses grouping the negative and the 4 together, this is going to be -4 times -4, which is +16. And again, anything that was not involved with that exponent is going to be left alone. Then, after exponents comes multiplication and division. So I do see this division here, the 16 over 2 can also be read as 16 divided by 2. So I'm going to do the division next. 16 divided by 2 is 8. After division comes addition and subtraction, so there is subtraction here, but I am subtracting a negative. And you might remember from a couple videos ago that subtracting a negative is the same as adding. So I'm going to change this minus minus into 8 plus 4, which is going to give me a final answer of 12. Now, when you have an expression with multiple variables, we already sort of covered this back in the very first video when we did a little intro to algebra. We had some formulas that involved more than one variable. So just as a recap, when you're evaluating expressions with multiple variables, you're going to plug the appropriate number in for the appropriate variable. So let's take this expression, x squared minus 3xy, and we're going to evaluate this when x is equal to 1 and y is equal to 2. So what we're going to do is in every single spot that we see in x, we're going to replace it with 1. And then in every single spot that we see a y, we're going to replace it with 2. So I see an x right here and right here. So in place of both of those x's, I'm going to substitute 1 with parentheses around it. Then in place of this y right there, I'm going to replace it with positive 2. Anything that is not an x or a y needs to be left alone and left exactly where it is. So in place of this x, I'm going to substitute 1 with parentheses around it. I'm going to leave the exponent alone. I'm going to leave that minus 3 alone. And then in place of this x, I'm also going to replace it with 1. And then in place of this y, I'm going to substitute 2. Then from here, I'm going to follow order of operations and simplify it. So I have exponents and I have subtraction and I have lots of multiplication. Of those operations, which one would go first? The exponent would go first, so I'm going to do 1 squared first. So this will be the same as 1 times 1, which is 1. Then I have a whole lot of multiplication. So again, I'm going to do the multiplication in pieces in the order that they appear when I read this from left to right. So I'm just going to leave this 1 alone, and I'm going to work through this string of multiplication just 2 at a time. Remember, a number always takes the sign to its left. So this 3 is technically negative. So I'm going to do -3 times 1 first. So -3 times +1 is -3. Then I'm still not quite done with the multiplication. Next, I'm going to leave the 1 alone. Next, I'm going to do -3 times 2. So -3 times a +2 is going to give us -6. And then 1 minus 6 or 1 plus -6, whichever, is going to give us a final answer of -5. So We're going to do that same thing with each of these. Now, I cannot stress enough that when you substitute a number in for a variable, especially if there is either multiplication attached to that variable or an exponent with that variable, you have to use parentheses, especially if what you're plugging in is negative. So I have two different expressions here, and I'm going to evaluate each of these expressions when x is equal to -3, when y is equal to +2, and when w is equal to -5, and you're going to use order of operations to fully simplify your answers. So I actually want you guys to try these. So I want you guys to pause the video, give these two a try, and then resume the video when you are done working. Okay, so we're going to take 2w squared minus 3y cubed, and we're going to evaluate it when w is equal to -5, and you absolutely need parentheses here, and when y is equal to 2. So in place of this w, I'm going to substitute it with -5 with parentheses around it. And then in place of this y, I'm going to replace it with +2 with parentheses around it. And anything that is not a w or a y needs to be left alone and left exactly where it is. So I'm going to leave this 2 completely alone. I'm going to replace w with -5. And then I'm going to raise it to I'm going to leave that exponent alone. Then I'm going to leave the -3 alone. And then in place of y, I'm going to replace it with -2. And then I'm going to leave that exponent of 3 alone. And there's a lot going on in this expression. We've got a couple of different multiplications, we've got a subtraction, and we've got a couple of exponents. So of those operations, exponents are going to come first. So I'm going to do each of these exponents, and this is where the parentheses were absolutely essential. Because over here with this -5 squared, since the negative is grouping together, since the parentheses are grouping together the negative and the 5, both the negative and the 5 are both being squared. So this is going to be the same as -5 times -5, which is +25. Then I'm going to leave this -3 alone and do the same thing over here. So this 2 to the 3rd power, remember, is not the same as 2 times 3. This is 2 times itself 3 times. So 2 times 2 times 2 gives us 8. After the exponents, let's look at what we have left over. We have lots of multiplication and we have some subtraction. So the multiplication in the order that they appear when you read this from left to right is going to go next. So 2 times 25 is going to give you 50. Next, to finish up the multiplication, we're going to do this multiplication that's right here. Now remember, a number always takes the sign to its left. So I'm going to leave this 50 alone, but this is actually a -3 times a +8. So -3 times +8 is going to be -24. So then, after the multiplication, now we're going to wrap this up with the subtraction. 50 minus 24 is going to give us 26, and then that will be your final answer. So then for this next one, we have x squared minus 5x plus 1, and we're going to evaluate this expression when x is equal to -3. And since the same variable appears more than once, I'm going to plug -3 with parentheses around it into every single spot that we see in x. So I'm going to plug -3 in right there with parentheses around it, and I'm going to plug in a -3 with parentheses around it right there. Anything that is not an x needs to be left alone and left exactly where it is. So I'm going to replace that x with -3. I'm going to leave the exponent alone, leave the -5 alone. Then I'm going to substitute -3 in for that x, and then I'm going to leave the +1 alone. And then we're going to simplify this using order of operations. So there's a lot of operations here. Let's go through what we've got and see which should go first. I've got an exponent, I've got subtraction, got some multiplication, and I've got some addition. So of those operations, which one would go first? The exponent would go first, so I'm going to do the exponent first. Now this is where you needed the parentheses. Parentheses -3 means that both the negative and the 3 are both being squared. So -3 times -3 is +9. After the exponent, next we're going to do the multiplication. Now remember that a number always takes the sign to its left. So I'm going to leave this 9 alone. I'm going to leave this plus 1 alone. And this 5 is technically negative. So this is technically negative 5 times negative 3. Now a negative times a negative is a positive 15. And then I'm going to do the addition. Now, since order doesn't matter with addition, you can do this in any order that you want. It doesn't really matter. If you want consistency, you can just add in the order that they appear from left to right. So 9 plus 15 is 24, and then 24 plus 1 is 25. But with addition, you have some flexibility. You can do addition in any order that you want. So we're going to do the same thing with these. Now we're going to evaluate each of these expressions when a is equal to 3, when b is equal to 4, and c is equal to negative 2. And these are examples of expressions where on either the top and or bottom of a fraction, we have another operation. So you do have to remember that when you see that, you need to put parentheses around that operation because you can only divide two numbers at a time. So we're going to take c divided by 5 minus a. In place of c, we are going to plug in negative 2. And then in place of a, we're going to plug in 3. Anything that is not a c or an a needs to be left alone and left exactly where it is. So I'm going to replace c with negative 2. I'm going to leave the divided by alone. And then on the bottom, I'm going to leave that 5 alone. I am going to leave that subtraction alone. And then only in place of a, I'm going to replace it with negative 3. Now remember, when you see another operation inside of a fraction like this, you do need to put parentheses around it. So there are implied parentheses around that 5 minus a or that 5 minus 3, which means parentheses always need to go first. So 5 minus 3 is 2. Then negative 2 divided by positive 2 gives you negative 1. So remember, you can only divide two numbers at a time. So when you see another operation inside of a fraction, you have to put parentheses around it and do that first before any dividing happens. So I actually want you guys to try that for this next one. The expression is b plus c divided by b minus c. And I want you guys to evaluate this when b is equal to 4 and when c is equal to negative 2. And I will give you a hint. You need parentheses around that numerator, and you need parentheses around that denominator. All right, so we're in place of every single spot we see a b, I'm going to plug in 4, and then in place of every single spot we see a c, I'm going to plug in negative 2. Anything that is not a b or a c needs to be left alone and left exactly where it is. So in place of this b, I'm going to plug in 4. I'm going to leave that plus alone, and then in place of c, I'm going to plug in negative 2. Then on the bottom, again, I'm going to leave the parentheses alone. In place of b, I'm going to substitute 4. Going to leave that minus sign alone, and then in place of c, I'm going to plug in negative 2. So yes, we do have a double negative in the denominator. So then in the numerator, 4 plus negative 2 is the same as 4 minus 2, which is 2. And then down here in the denominator, that double negative, that minus negative 2, you can change that to addition. So 4 plus 2 will give you 8. And then yes, 2 over 8 is not a whole number. You can have an answer that's a fraction. Just please reduce it. 2 over 8 does reduce to 1 over 4, and then 1 over 4 is going to be your final answer. Oh, sorry. 4 plus 2 is, 6. I got distracted by something else over here. So 2 over 6 does simplify to 1/3. I'm having some technical issues if you can't tell. So 2 over 6 does simplify to 1 over 3, and then that is going to be your final answer. Sorry about that. Now, when you're actually simplifying expressions, so that was just evaluating variable expressions, there are going to be plenty of times when you have absolutely no idea what x equals or what y equals. And all you will have to be doing is just simplifying the expression and reducing it as much as possible. So when we're simplifying a variable expression, that is different than evaluating. When you evaluate an expression, you're actually plugging a number in for a variable and simplifying. But when you don't know what the variable equals and you're not told to plug a number in for a variable, if you're just simplifying the expression, order of operations and all that is still going to apply, but you will have this concept of what are called like terms, especially if your expression has more than one variable. Now, like terms are the same, come on, there you go. Like terms are the same variable to the same power. I can't emphasize enough that both of those are necessary for two terms to be like. You need to have the exact same variable, so the exact same letter, and the exponent needs to be the exact same. But if you have two terms with the same variable to the same power, you can do what's called combining them. Now, constants, if you remember from the first video in this series, constants, which are numbers with no variables, are also considered like terms. So if you have two different numbers that do not have any variables attached to them, they are also considered like terms. Now, if you have two terms that either do not have the same variable and or do not have the same power, they are called unlike terms. We're going to get into combining like terms in a little bit, but what I have here are four expressions that contain two terms. And what we're going to do is we're going to figure out whether these terms are like terms or whether they are unlike. Remember, in order for two terms to be like terms, they need to have the same variable raised to the same power. So for 3a plus 5b, remember, terms are only separated by a plus sign or a minus sign. So 3a is considered one term, and 5b is considered one term, and the plus sign is what separates them. So, are these terms like terms? They are not, because a and b are different variables. So since they have different variables, they are unlike terms. Now for this next one over here on the top right, we have n minus 6n. Again, terms are only separated by addition or subtraction. So n is considered one term. This minus 6n is considered another. Do they have the same variable to the same power? Yes, they both have an n, and I don't see any exponents. There's technically an exponent of 1 here. We're going to get to that in another video. So since they have the same variable to the same power, these are like terms. We're going to get into how to combine these in a little bit, but for now, we're just identifying that these are like terms. Now for this next one over here on the bottom left, we have 4x squared plus 2x. So 4x squared is a single term. The plus sign separates them, and 2x is its own term. So we're going to figure out whether these are like terms or unlike terms. Now remember, in order for two terms to be like terms, they need to have the same variable to the same power. So yes, they both have an x on it. So yes, the variable is the same, but the powers are not the same. This has an exponent of 2, and this technically has an exponent of 1. So because the powers are different, even though they are both x's, these are still unlike terms. Because like terms need to have the same variable and the same power. You need to have both of them. Now you might also remember that anything that is linked together with multiplication is all considered one term. So for this next one, this 2a squared b, since there's hidden multiplication there and there, this is technically all one giant term. Same thing for this negative 3a squared b. This is all, again, one giant term. Now, when your terms have more than one variable, as long as they have the same combination of variables to the same combination of powers, they can still be considered like terms. So this first term had an a squared b. This second term had an a squared b. They do have the same combination of variables to the same combination of powers, so these are technically like terms. Now remember, Like terms are the same variable to the same power. When you have an expression that has like terms in it, you can combine like terms. So that just means putting them together into one single term that has that same variable to that same power. So here's how to combine like terms. You combine the like terms by adding together the numbers in front. More formally, you combine like terms by adding their coefficients. Now this is also important. When you combine like terms, you never change the variable or its exponent. I cannot emphasize that enough. The only time you ever change exponents are when you multiply variables together, which we're not even going to get to in this course. That's intermediate algebra. So when you are just combining like terms, you just add the numbers in front. Do not change the variable and do not change the exponent. The only exception to this is when you multiply a variable by 0, because 0 times anything is still 0. But other than that, when you combine like terms, you do not change the variable and you do not change the power. So what we're going to do is we're going to identify any like terms in these expressions, and then we are going to combine them. Remember, a number always takes the sign to its left. So I have 2x plus 3y minus 5x plus y. Just to point it out, if you do not see a number in front of a variable, like I'm looking at this y on the end here, you can always assume that there is a 1 here. So this can be thought of as 1y. So let's first look at 2x. What would a like term be to 2x? Well, that would be this term here, which has an x on it. And since that 5 is technically negative, this is all considered one term. So 2x and minus 5x are like terms. Now let's take a look at 3y here. So what would be a like term to positive 3y? Well, that would be this positive 1y right here. So 3y and 1y are also like terms. So to combine like terms, we're going to add together the numbers in front. So to combine the x terms, 2x plus negative 5x, 2 plus negative 5 is negative 3, and then we're going to leave the x alone. Because remember, when you combine like terms, you do not change the variables and you do not change the powers. And then we're going to do the same thing to the 3y and the 1y. So I'm going to take positive 3 plus positive 1, which gives us positive 4y. And I'm going to separate them with a plus sign since this 4 is positive. Now, here's how to know when you're done. You're done when all you have left are unlike terms. So negative 3x and 4y, they're not even the same variable, so these are unlike terms. So this is actually fully simplified. We have absolutely no idea what x and y equal. So because we don't have a clue what x and y equal, we can't actually plug anything in for x and y. So this is as much as we can do to simplify this. So I'm going to take a look at this next one over here on the top right, 4x squared minus 2x minus 5x plus 4. We're going to first identify the like terms, and then we are going to combine them. So let's start with 4x squared. A like term with 4x squared would be a term that has an x to the power 2, which unfortunately I do not see any other terms that have an x and a power of 2. So when that happens, when you have a term that doesn't have any like terms, you just leave it alone. So I'm just going to leave that 4x squared alone. It's going to be part of your final answer, and you're stuck with it. But let's take a look at positive 2x. Notice I circled the sign to its left. A term that is like with 2x would be another term that has just an x on it, which I see one right here, this minus 5x. So these two are considered like terms, so let's add them together. So you combine like terms by adding the numbers in front. 2 plus negative 5 is negative 3, and then I'm going to leave the x alone. Then taking a look at this last number here, this plus 4, a like term to this would be another number that does not have a variable. So in this expression, I don't see any other numbers that have no variables attached to them, so there's nothing that's like with this plus 4. So since there's no like terms with that plus 4, I'm going to leave the plus 4 alone. And then this is actually going to be our final answer, because 4x squared minus 3x plus 4, these are all unlike terms, and you are done when all you have left are unlike terms. So then for this next one down here on the bottom left, let's first identify if these two terms are like terms. So I have this 1/2 x plus 1/4 x. They have the same variable to the same power. So since they have the same variable to the same power, these are considered like terms. You combine like terms by adding their coefficients. So I'm going to take 1/2 plus 1/4, which is 3/4 x. And then yes, you can have a coefficient that's a fraction, so this is going to be your final answer. And then for this last one, so I want you guys to actually take a minute to pause the video and combine like terms to simplify this last one. So go ahead and give this one a try. All right, so let's first identify the like terms. So the like terms, let's start with this negative 2w. What term would be like with this negative 2w? Well, that would be this negative 3w over here. Notice how I keep circling the signs to their lefts because a number always takes the sign to its left. So I'm going to combine these two terms by adding the numbers in front. So negative 2 plus negative 3 would give us negative 5w. Then I'm going to do the same thing for the z terms. So I've got this negative 5z and this minus z. Now when you see, again, a variable just by itself with nothing in front, you can always assume that there is a 1 here. So this is technically a negative 1z. So I'm going to combine these terms by adding the numbers in front. So negative 5 plus negative 1 is negative 6z. And then let's check to see if we are done. I have negative 5w minus 6z. These two don't even have the same variable. So since they don't even have the same variable, these are unlike terms. And this is going to be as simplified as it's going to get. So that is going to be your final answer. So what we're going to do for each of these is we're either going to combine the like terms or state that it is not possible. So for 2x squared plus x, are these two terms like terms? Unfortunately, they are not, because this is an x to the power 2, and this is technically an x to the power 1. So even though the variables are the same, the exponents are technically different. So because they don't have the same power, these are unlike terms. Because they're unlike terms, this is fully simplified. There's nothing to do for this. This expression is fully simplified. There's nothing we can do with it. They're unlike terms. Now remember, like terms, when you have more than one variable involved, are the same combination of variables to the same combination of powers. So I'm looking at this next one here on the top right, this 8m squared n squared plus 2m squared n squared. Remember, anything that is linked with multiplication is all considered one term. So since there's multiplication there and there, this is all one giant term. Terms are only separated by plus signs and minus signs. So that plus sign separates it into another giant term. So 2m squared n squared is also another giant term. Do they have the same combination of variables to the same combination of powers? Which they do. They both have an m squared and an n squared. So since these are like terms, I'm going to combine them by adding together the numbers in front. So 8 plus positive 2 is positive 10. And remember, when you combine like terms, you leave all variables and all powers alone. So your final answer is going to be 10m squared n squared. So I want you guys to actually try this last one. I want you guys to figure out, are these two terms like terms? And if so, I want you to combine them. All right, so remember, anything that's linked with multiplication is all considered one giant term. So since there's multiplication there and there, this is all a giant term. This plus sign separates it into another giant term. So negative 6a squared b and 5a squared b are your two terms. And these are like terms because they both have an a squared and a b on them. So since they are like terms, we're going to combine them by adding the numbers in front. So negative 6 plus 5 is going to give us negative 1a squared b. And this is technically not wrong, but you technically don't need the 1 in front. So negative a squared b, is technically how we would want to have it written. But you're not wrong if you put the 1 there, it's just not necessary. So negative a squared b is going to be your final answer. So simplify is like a generic direction, meaning if you see like terms, combine them. And when we get to the part 3 of the video lectures on these two sections, we're going to find that there are going to be other properties that we can do as well. So simplify means just do any properties that you see present and combine any like terms till you are left with only unlike terms. That's basically what simplify means. So to simplify 2x plus 6x, all we have to do is combine any like terms that we see. So are these two like terms? They are. They both have an x. And since they're like terms, we're going to combine them by adding the numbers in front. 2 plus 6 is 8x. Same thing over here with this a minus 8a. Remember, if you don't see anything in front of a variable, you can always assume there's a 1 there. Let's first identify whether we can simplify this. Are these two terms like terms? Which they are. Since they're like terms, we're going to add together the numbers in front. Positive 1 plus negative 8 is negative 7a. Now, when you're simplifying an expression, the only terms that you can combine are like terms. So I have 6y minus y plus 5. Let's first identify what the like terms are. So the like terms are this 6y and this minus 1y. This plus 5, another term that would be like with this plus 5 would be another number that does not have a variable. And since I don't see any other constants here, there's nothing that we're going to combine with this plus 5. So this plus 5 is just going to be part of our final answer here on the end. Then let's combine 6y minus 1y. So 6 minus 1 is 5y. So your final answer is going to be 5y plus 5. So then for this last one, you can have more than two terms that are all considered like. So 3a plus 2b minus 5b. These are all like terms because they all have a b to the power of 1 on them. So since these are all like terms, you can combine all of them. And remember, from order of operations in the previous video, if you see an expression that has both addition and subtraction, you need to do the addition and subtraction in the order that they appear when you read the problem from left to right. So when you read this from left to right, the addition does come first. So I'm going to combine those two terms first. Positive 3 plus positive 2 is positive 5b. Then I'm going to do the subtraction. So since they're like terms, I'm going to add the numbers in front. 5 minus 5 is 0. Now technically, this is 0b. But you might remember when you first learned how to multiply that 0 times anything is 0. And that's the same thing here. It doesn't matter whether you're multiplying 0 by a number or a variable. Because a variable is an unknown number, 0 times b is still 0. So when that happens, when your coefficients add up to 0, your final answer is just 0. Now, another thing that we're going to cover in this video is what happens when you multiply a variable term by a constant. We're not multiplying variables together, so we're not taking 2x times 3x. We're not going to be doing that. That is in a totally different course. This is going to be taking a variable term like 3x and multiplying it by a constant such as 2. So if only one of the things that are being multiplied has a variable, what you're going to do is you're going to leave the variable alone. So when you have a variable expression 3x multiplied by a constant 2, all you will have to do is multiply the numbers together. That's it. You just multiply the numbers together and leave the variable alone. So 2 times 3x would be 6x, and that's it. You wouldn't do anything with the variable. You wouldn't do anything with the power. You just leave the variable alone. So again, we're not going to be multiplying variables together in this class. That's going to be the next class, intermediate algebra. So we're going to take each of these expressions, these are all variable terms multiplied by a constant, and we're going to multiply/simplify them. So I have this 2 times negative x. And remember, if you don't see anything in front of the variable, you can always assume there's a 1 here. So this is positive 2 times negative 1x. So what we're going to do is we are going to multiply the numbers together. Positive 2 times negative 1 is negative 2, and we're going to leave the variable alone. So same thing with 3 times 2x. We're going to multiply the numbers together. 3 times 2 is 6. And since only one of these has a variable on it, we're going to leave the variable alone. So I want you guys to actually try each of these. Even if the variable has an exponent like this one down here, again, you would just multiply the numbers in front and leave the variable and its exponent alone. So I want you guys to pause the video and multiply each of the remaining ones on this slide. All right, so taking a look at negative 5 times negative 3x. We're going to multiply the numbers together, so negative 5 times negative 3 will give us positive 15. And since only one of these factors has a variable, we're going to leave the variable alone. Now remember, order does not matter with multiplication. So 2x times 6 here, it doesn't really matter. When you're multiplying a variable term by a constant, you still just multiply the numbers together. 2 times 6 is 12, and you leave the variable alone. So it really doesn't matter what order the multiplication is in. The same rules for that multiplication still apply. Now for this next one, for 3/2 times 2/3 x, yes, we're going to be multiplying fractions together. You might remember that when you multiply fractions, you can cross-reduce, which means take a look to see if any of the numbers on the top have any common factors with any of the numbers on the bottom. You should also take a look and see if any of the numbers on the top are the same as any numbers on the bottom, which I see a couple of those. So I see a 3 on the top here and a 3 on the bottom here. 3 divided by 3 is 1. Same thing here. 2 divided by 2 is 1, so these all cancel out and become 1. So 1 times 1 is 1x, which you technically don't need the 1 in front because anything times 1 is itself. So x times 1 is just x. So your final answer is just x. So then for this next one, for this negative 2 times 3x squared, I'm going to multiply the numbers in front. So I have negative 2 times positive 3, which is negative 6. And since only one of these had a variable, I'm going to leave both the variable and its exponent completely alone. So then same thing for this next one. We have negative 5 times negative 10x cubed. I'm going to multiply the numbers in front, so negative 5 times negative 10 is going to be positive 50. And since only one of these had a variable, I'm going to leave that variable and its exponent completely alone. So your final answer is going to be 50x cubed. And then for this last one, I have negative 3/4 times 2/3 x. I'm going to multiply the numbers in front, and I'm going to be leaving the x alone. So remember, when you multiply fractions, let's cross-reduce. I'm going to ignore the negative for a moment and then just focus on the cross-reducing. So this 3 is going to cancel out with this 3 and become 1. And then 2 and 4 have a common factor of 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. So then a negative times a positive is a negative. 1 times 1 is 1. Divided by 2 times 1 is 2. X. So your final answer is going to be negative 1/2 x. So that is all that we are going to cover in this video, which is simplifying variable expressions and more advanced evaluating variable expressions. In the next video, we're going to be doing some more advanced simplifying expressions, and we're going to cover a whole bunch of important properties of real numbers. So stay tuned for that video. Thank you all very much for watching, and I will see you in the next video for part 3 of 7.1 to 7.7 to 7.8. Bye-bye.